So arc measure is defined by the central angle, and the central angle is just this. I remember yesterday I was saying if you had something like A, B, maybe C out here, the measure of arc AB is defined by the central angle. So if this kind of looks like, I don't know, 85 degrees. This central angle is 85, so I'll write that down. Central angle is 85 degrees. So that means the arc measure. So the measure of arc AB is also 85 degrees. And whenever you just have AB without 3 letters, they're talking about the minor arc, which is the shortest way around. If they meant the longer way around, they would have said ACB or BCA. So that would be this. If we wanted to know the actual arc length, this you don't have to write down. But if you wanted to know the arc length, I'm going to try and draw the same idea here, 85. Say this was a radius of 10. Right here, I don't have the radius, but I can still write down the arc measure. It's 85 degrees out of the total 100 or 360. Here, if this is 85 degrees, well, then this is 85 out of 360 times whatever the circumference is. We're not going to be dealing with that today. But if we have the radius, we can calculate the circumference by doing 2 pi r. We mentioned that yesterday. So that's what we would have here. So this would be arc length. You don't have to write that. We're looking at arc measure, which is just in degrees, and it's based on the central angle. Are there any questions about that? We're getting right to the examples, and they're super easy for the first part. No questions? So the central angle just intercepts this arc AB. I think that's pretty straightforward. We'll move on from here. So on this, it says find the measure of arc AC. Find the measure of arc AC. That means from here all the way down to here. It doesn't mean, I guess, minor arc. If you want the longer way around, there would have to be a letter here, and it would say that third letter. So the minor arc AC, find the measure. So yeah, you just take, if AC is the whole entire thing, then you're just adding those together. 170 is the measure of arc AC. Simple enough. So first, AD is a diameter, which means it's a straight segment all the way through the center. CE is a diameter all the way through the center. Find the measure of arc AB. If there's no third point in the name of the arc, then you're going the short ways around for the minor arc. So AB, you're trying to find this. I'll give you a second for that. I don't know if you assumed something that I didn't or if I just did it wrong, but let's see. Where's my red pen? On this, listen, shh. I don't know how much this is. You can't assume that this is 90 degrees. You can't assume that this is 90 degrees. Is that something that you assumed or no? Okay, we don't know that. Maybe I should have exaggerated it, but it doesn't tell us that those are 90 degrees. Just that they are diameters. I don't know if this is 90 degrees. In fact, the way that I drew it, this angle is bigger than this angle, right? And it doesn't say they're 90 degrees, so they're not 90 degrees. Maybe try with that information. Okay, well, I guess I can just say, listen. CE is a diameter, right? So how many degrees is from here to here, from C all the way to E in this direction? 180, right? Which means this is also 180 here. Where else is it 180? A to D in both directions, right? Okay. You think you got it? All right, hold on. I feel bad. I forgot to put something in. So, oops. You'll be able to get it after this for sure. Okay, so now try it. Sorry. So, with this new information, because, I mean, you couldn't do it without, I know that this is a straight line or segment, and this is a straight segment, right? That creates vertical angles, where this is 93. That means this also has to be 93. Do we see that? If this is 93, that means this is also 93. And then we can go 93 minus 38. There's other ways to do it, but we wanted this, right? So the measure of arc AB equals 55 degrees. I guess we could have done it like, we could have figured out this one, right? If this is a straight line, I should look here. If this is a straight line, then I can do 180 minus 93. 7, 8, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8. Do we see that? If this is a straight line, then this has to be 87, because I can subtract from 180. Well, if this is 87, this is 38, then I could, again, subtract 38 and 87 from 180, and I would get 93. Sorry, not 93, 55. Okay, so 2 ways to do that. Sorry about not putting down the actual number. Yeah, this one's an easy one, actually. AB is a diameter. What is the measure of arc ABC? Yeah. Brody? 249. Yes. So, look. This is a straight segment, which means this is 180 degrees. And then 180 degrees plus 69 will equal to 49. That's what you said, yeah?
I did 360 minus 69.
If you did 360 minus 69, that includes this, and we don't want to include this. Because it says ABC, ABC. Yeah. So, yeah, A, B, C. I don't go this way and then back. It's A, B, C. So that would be 180 plus 69.
So the way I did it would be BAC.
No, what did you do? You did 360 minus 69? You did either CAB or you did BAC. Is that what we said? BAC? Oh, yeah, BAC. So XZ is the diameter of A. What is the measure of arc YZ? What is this measure there? So on this is important because it tells you what's equal to 180. XZ is a diameter, so that means all of that adds up to 180. So 11W plus 5W plus 4, those angles have to add up to 180. And then those are like terms, so you just combine them. 16W plus 4 equals 180 minus 4. 16W equals, what is that? 176. Divide by 16. W equals, is it 11?
Yeah.
But you have to plug it back in to this because we're looking for that angle, which is the same as that one. So 5 times 11 plus 4.
I did 4 times 11 on aspirin. I meant 5.